SwayamPrabha. Digital India. Educated India.
Hello, good morning, welcome back. So, we are discussing the product architecture. In the last class, we discussed about the product architecture and the two types of architecture. One is the integral architecture and the other one is the modular architecture. And then we saw how the modules can be identified using some standard procedures. So, one of the method we discussed in the last class, where we try to group the functions which have something common, some flows common, and then use some common sense approach to get the modules identified. And then we found that it has got some limitations because there are no specific rules to identify the modules, and many times we may end up with wrong answers using this method. And therefore, we go for another method which we call it as heuristics based approach or module heuristics. So, we use some heuristics to identify the possible modules and then combine some of these modules depending on what actually we are finally looking for. So, the module heuristics is a method of examination in which the designer uses a set of steps empirical in nature yet proven scientifically valid to identify modules in a design. So, we use this method to identify modules in a product, but the method is more of an empirical in nature. So, it is not analytical in this case. So, it is an empirical method, and it has got some steps, already identified steps, which we called as the heuristics, and then identify modules. So, this is known as the heuristics based approach for identification of modules in a product. And we have multiple modules in this, multiple modules can be identified using multiple heuristics. So, we have different heuristics to adopt. So, identify modules using functional dependencies or the manner in which one set of subfunctions depends on the results of other subfunctions. Okay. So, we look at the functional decomposition again, and then I try to identify what kind of functional dependencies exist between different elements and how the set of subfunctions depends on the results for other subfunctions. Okay. How the results from a particular group of subfunctions goes to the another set of functions and how they depend each other. So, these are the things that we look in the heuristics method, and based on this we identify the main heuristics to be used for identifying the modules. So, the procedure is like this. So, you develop a well defined function structure, that is in the case of previous case also we did the same thing. We develop well defined function structure based on the flows, that is the material, energy and information, and then identify modules using the three heuristics method. So, these are the three heuristics that we want to use. The first one is known as a dominant flow heuristics, then the second one is a branching flow, and third one is known as a conversion transmission heuristic. So, we develop the look at the function structure and then try to see what is the most dominant flow in that function structure. So, as you know that the function structure will be having all the functions identified in within the box, and then we look at this function and then see what kind of flows are there. So, we have the material, energy and information. So, we look at in this case which one is the most dominant flow. So, in some case there will be more than one, but we will try to identify all the dominant flows in this function structure, and then try to combine all those functions which are actually part of this or it actually is connected with this flow as a module. So, that is the way how the dominant flow works. For example, if you take that in the case of previous case also, though it was not based on any rule, we try to see what is happening to the paper, and then we try to identify all those functions through which the paper passes and actually comes out, and then we can actually combine all those functions as a module. So, that is known as the dominant flow heuristics. So, there can be more than one dominant flow. So, we can actually identify all those dominant flows, because there will be some flows which are not very important or not very dominant, then we do not make modules based on those flows. Only the dominant flow we consider and then take the identify the module. The next one is known as the branching flow. So, branching flow basically talks about the same kind of the flow analysis. So, we look at one flow coming into the product. Suppose this is a material coming into the product, and then it passes through some functions, and then it actually divides into two and then goes out. So, this can be one way of there can be functions in the structure such that the flow gets branched into multiple flows or multiple loops. Then each of these can actually be considered as a module. So, that is the branching flow heuristics. So, whenever there is a flow branching into multiple branches, then each branch we consider it as a module. So, that is the branching flow heuristics. Then the third one is known as the conversion transmission. So, as the name suggests, whenever there is a conversion of a flow into something else and it is getting transmitted, then we can take that as a module. So, conversion transmission module we can identify. So, for example, when electricity is coming into the product, then after some time it may get converted to mechanical energy, and then it will be get transmitted by some means to some other function block. So, we put this conversion and transmission as a module. So, whenever there is a conversion and a transmission or transmission, can be only conversion or it can be only transmission. So, in this case, when there is a conversion and transmission, both can be taken into a single module. So, that is basically the conversion transmission heuristics. So, using these three, so in all the cases we use all the three heuristics and then try to identify all possible flows, possible modules. So, we will try to identify all possible modules using these three heuristics. So, there will be lot of overlaps also happening, because a dominant flow module may be part of the conversion transmission module, or it can be part of the branching flow module also, but we will try to identify all possible modules using the three heuristics, that is the dominant flow, branching flow and conversion transmission heuristics, and then try to eliminate these overlaps and then try to identify modules. So, based on these identified all potential modules, we try to identify the overlaps and then eliminate the overlap and then create the modular identify the modules. That is basically the procedure for heuristics based module identification. Okay, so this is what I already explained. So, the dominant flow defined by a dominant flow, set of sub functions which a flow pass through from entry to the flow in the system to exit or conversion of the flow within the system. So, till the flow gets coming out of the product or it gets converted to some other flow, all those functions which will be part of that is known as the dominant flow proposition. Okay. So, all the material is coming here and the material is going out, then we consider this as the module. So, we will consider this all these functions as the as part of the dominant flow module. That is the dominant flow proposition. Okay. And now, the branching flow, as I told you, parallel function chains associated with a flow that branches constitute modules. So, you can see that something is coming here and then it actually branches out. Okay, this is the interface. So, it is coming here and then it is branching out to different branches. So, we will take all these as the modules. So, potential branching modules 1, 2, 3 like this we will take. So, this is known as the branching flow heuristics or branching flow modules. So, each of the modules interfaces with the remainder of the product through a flow at the branch location. So, this location will be the interface for these modules with the rest of the product. So, the product maybe the outer box will be somewhere here, but this each module we can see that has got a common interface with this product or the rest of the product using this one. This becomes the common interface. So, that actually identifies the common interface, and then we can see that okay, these 3 modules are, these 3 can be considered as modules which has got a common interface with the rest of the product. Okay, that is known as the branching flow heuristics. And the last one is the conversion transmission. So, a conversion subfunction or a conversion transmission pair or proper chain of subfunctions form a module. So, that is basically the conversion transmission. So, you can see that okay, there is a conversion only, then you can say conversion module, convert from flow A to B, that is convert electricity to mechanical energy, okay, or electricity to torque, whatever they. So, that becomes the conversion module. Or there is a conversion and then transmission, that is you convert flow A to flow B, that is from electrical energy to mechanical energy, and then transmit torque. So, that will be the conversion transmission pair. Or you can actually have combination of these, converts, then another flow, then again transmit, that also can be considered as a conversion transmission chain. So, you have conversion, then it flows, I mean passes through some function, again it gets transmitted, then also can be considered as a module. So, this is the conversion transmission chain. So, this way you will be able to identify the modules using these 3 heuristics. So, you have the dominant flow, you have the branching flow and the conversion transmission. So, most of the potential modules that can be identified in a product can be identified using these 3 heuristics. And as I told you, there will be lot of overlaps between these modules, identified modules, and then as designers we need to sit together and then identify the overlaps and then remove the overlaps and then look at the interfaces and accordingly decide okay, oh, these are the potential modules that can be there in the product. Again, that decision depends on many other factors like the number of products you want to introduce and the generation portfolios that you are planning to have. So, all those things also affect the final decision, but potential modules can be identified using these 3 heuristics. So, we will see this or we look at some examples to see how this can be implemented in a practical case. So, this one again we already saw this as an example earlier using the first method where we try to combine the functions which has got something in common. So, we will this is an electric pencil sharpener. So, now we can actually look at is there a dominant flow, branching flow or conversion transmission. So, you can see this electricity as a dominant flow here. Electricity is coming, import electricity, actuate electricity, convert to rotation. So, up to here it is electricity. So, we will actually put these 3 functions into a module saying that okay, oh, this is the electricity module, and after conversion it is becomes something else. So, we do not put those functions in part of this one. Then similarly, we look into the pencil. So, the pencil is coming to the product, then import solid, send solid, guide solid, then separate solid, export solid. So, all those things are transmit rotation energy, of course, the energy is passing given to the solid. So, it actually becomes part of it and export solid. So, the solid is coming out. So, till the pencil is coming in and till it goes out, it has got many functions. So, we put all those things into the dominant flow module, right. So, these are the 2 dominant flows that you can identify in this product, and of course, there are many other flows actually hand and other things are there. So, but we do not consider, but we can actually consider as a so this actually considered as another module, potential module, that you have the guide solid, store solid and export solid, which is actually a storage module for the shavings of the pencil. So, that can also be another one because this is also a potential module. Right. Now, there can be other opportunities also. So, this actually becomes a branching flow module because this actually branches out from here, right. So, this actually goes out from here and then it comes, sorry, this material solid, one branches here and one branches out here. So, this can actually be considered as a branching flow and therefore, this becomes another module, branching flow module, and this actually becomes another one, but since only one function is there, we need to see whether can be taken as a separate module or not. Otherwise, this becomes a part, this becomes part of the branching flow module. So, these two are the dominant flow modules and this one is a branching flow module. Now, this can actually be considered as a conversion. So, here you have a conversion to convert to electrical rotation and then change rotation energy and transmit rotation energy. So, this can be considered as a conversion transmission chain and this will be another potential module, a conversion transmission module. So, now we can see by using the dominant flow you will be able to clearly tell what are the potential modules that can be using the heuristics we will be able to tell what are the potential modules that is possible within this product. It is not that we will make everything as a module, we will look into this and then see what can be a module, what cannot be a separate module, and we will decide how to go about identifying the actual modules in the product. For example, this dominant flow module import electricity, actual electricity, then convert transmission, conversion and transmission. So, there is an overlap here. So, you need to decide whether you want to make this conversion transmission as a module or you want to make this as a module part of this. So, that actually is left to the designer based on the requirements of the product as well as the concerns, other considerations, they can decide which one to be chosen. So, we will take another example here, which is again a power screwdriver. So, we saw this function structure earlier, inputs like these are the inputs, you can see the hand, human force, electricity, screw, these are the inputs and then these are the outputs that you can see. Now, here again you can apply the dominant flow heuristics. So, you will have one for the electricity. Okay, so, this is the electricity, based on the electricity you can identify one supply electricity module, and then you can have basically here is a conversion transmission module. So, here is the change torque, transmit torque, dissipate torque. So, convert to electric energy to torque. So, this is a torque transmission module, this is the conversion. So, you have conversion and then transmission. So, you can put it as a conversion transmission module or a transmission module separately, and here there is a coupling solid. So, this the bit tool bits. So, coupled solid, secure solids, and of course, the separate solid also can be made part of this if you look for the dominant flow. So, this way you will be able to identify potential modules. And another one you can see is that here you can import hands, and you can see here actually it is getting branched to different branches. So, there are 3 branches for this one. So, we will see similarly human force also getting branched into multiple cases here. So, we can look at the branches here. So, this can be one branch, this can be another branch and this can be another branch. So, this way we will be able to get the branching modules also. So, the branching modules can be identified as, so coupling decoupling module can be a branching module. So, because we are using the hand force and hand force to do this, and that actually gets branched out. So, you have a coupling decoupling module and then you have a manual use module. So, this actually makes it possible to use manually. So, we will use that as a manual module and this as a positioning module. And then there is again this coming here. So, hand force, so it is an actuating module. So, this way again the hand force is used here for this this purpose. So, this hand force is coming here. So, there can be a branching module here also. This is basically the torque transmission module. So, looking at the branching of the hand force as well as the hand, you will be able to identify many modules as part of the branching heuristics. So, dominant flow heuristics gives you some modules, then you look at the branching flow module, that will give branching flow heuristics, that will give you some module. Similarly, now you go for the convert to electricity, so a conversion module and then transmission module also. Okay, so, converts and then convert to torque and transmit. So, that is the conversion and transmission module. So, convert, change and transmit. So, conversion transmission module. So, we use all the 3 heuristics separately and identify the potential modules, and as you can see here, there will be lot of overlap between these modules, and then remove the overlaps and then identify the actual modules needed. So, this is the way how we use the module heuristics to identify potential modules in a product. And this is only potential modules, as I told you, this is not the final one. The final module will be decided based on the by removing overlaps as well as taking into consideration other aspects of the requirement of the product. You should be able to look at the function structure and then should be able to apply the module heuristics to identify the potential modules. So, if you look at the function structure, again this function structure we already discussed in one of the earlier classes. So, I am not going into the details of how you get this function structure. So, you will be getting this function structure like this. So, the input will be filter T, ice, water, then electricity, then thermal energy, okay, that is thermal energy coming, and then alignment other things, okay, that is information. Now, you can see the dominant flows in this case. So, you can see that it is a dominant flow of filter and T. So, all these functions which are actually part of this will be become a filter T containment module. Then this will become an ice containment module, import solids, store solids, secure solids, that becomes the ice containment module, because that is the dominant flow here in this case. And similarly, of course, that will be actually continuing here also, mix solid and liquid until the come out. So, you need to look at those functions which are actually connected to ice and then combine all of them together in that module. Similarly, water, so, you have a water module here. So, you can see liquid containment module. And electricity, yes, electricity module, again it is a dominant flow. So, you have an electricity module, and this is part of the energy module. So, you have thermal energy coming from here. So, thermal energy is converted to thermal energy. So, now thermal energy becomes a flow. So, you can actually follow that and then try to identify all those modules connected to the thermal module. So, if you see that this is a filter T containment module. So, this is also part of the filter T containment module. So, that is why it is mentioned here. So, it is not stopping here. So, you need to look at what is happening to this T and filter. So, it is actually coming here and then going here. So, it becomes again part of the filter T containment. So, follow the flow and till it gets converted or till it comes out of the product, put all those functions as part of the dominant flow module. Okay, so, that is the module, that is the way how you can identify modules. Again, you can actually look at the branching, if there is any branching happening or if there is any conversion happening. So, all those things can be combined and then you can actually have different modules. So, there will be different such modules identified here. So, you can see this ice part of ice containment after T containment, and this is the brewed T can be another module. So, once the water converted to water, tea leaves, everything converted to brewed tea, that becomes another flow. So, you can actually put that as a module. So, this way you will be able to identify all potential modules in a product by simply following this module heuristics or applying the module heuristics and then getting the potential modules. Once we have all these potential modules, you try to identify the best possible module for the product, and that will be like this. So, you can see filter T containment, ice containment, water containment, electrical conversion, tea making unit and T containment. So, here this talks only about the filter and tea, here it is ice, it is water, and then there is an electrical conversion and there is a module which actually makes the tea, and once the tea is made, then this module takes care of all those the rest of the thing, that is the T containment module. So, in the structure or the product structure, now we know that okay, these are the important modules that need to be there in the product. Okay, so, we can now create a structure, product structure or a geometrical layout based on this, and you will be getting this as the possible layouts. So, we identified the liquid containment, we identified the electrical conversion, ice containment, T containment, filter T containment. So, these are the modules. Now, as a designer you can see okay, what way you would like to arrange them, so that you will get a at least a geometrical layout of the product based on these identified modules. So, we still do not have any physical form for all these things, but at least we know okay, these are the modules that need to be provided in the product, and these modules can be arranged in such a way that you will be getting all those functions needed. So, this is one way of side by side layout, or you can have a stacked concept also, like one over the other. So, ice T containment, filter T containment, liquid containment, like that, and then electricity and thermal conversion here, electrical conversion module here. So, the water will come through the electrical conversion, heat it, and then it will pass through the filter T containment, so that the T can be added, and you will be getting the T here. Then you can add ice, and you will be getting this as the T, ice T. So, this is again another concept or stacked layout that can be proposed for the product. Okay, so, now you see how things are progressing. So, we started with looking at the customer's requirement, and then looked at to satisfy the customer require what kind of specification to be provided and what kind of functions to be provided, and then from these functions how we can identify different modules needed in the product, and how these modules can actually be arranged so that we can get a product layout. So, this is basically the architecture of the product. And if you want to have multiple products in the family, we also we can do this by changing some of these modules to a different module. You will be getting a different product, a different product in the family. So, that is basically what the product architecture is all about. I hope you understood the basic idea of how do we identify the architecture of a product. So, to summarize whatever we discussed in the last few classes, we started with the portfolio architecture, and then we saw what are the different portfolio architectures existing, and the classifications of portfolio architecture, basically based on the modules or the integrated one, or I mean unshared architecture or modular architecture, and within the modular architecture what are the different possible options like modular family, modular generation, etc. And then we saw how do we actually choose the portfolio based on the customer's requirement. By looking at the population distribution as well as the segment distribution, we will be able to identify the changes needed in within the products, and therefore we will be able to identify a portfolio based on that. So, how many products to be offered and what should be the way in this product should be architected can be obtained in this case. And then we talked about the product architecture. The product architecture is how an individual product can be identified, or its architecture can be identified. So, how do we actually convert those functional blocks into physical chunks, and then how these chunks can provide the necessary functions. And here also we identified two important architectures, one is the integral one, the other one is the modular one. In integral, all the one physical blocks provides you multiple functions, and there will not be any clear distinction between the functional blocks as well as the physical chunks. And in modular we will have different modules providing different functions, and there can be clear interfaces between these modules. And at the end we saw how do you choose the architecture. Suppose we have we have decided to go for a modular architecture, how can we identify the modules within the product? That was the choosing the architecture. And we saw one as the basic clustering methods, where we use our intuition to come up with some modules based on the flows and how it is actually arranged in the function structure. The other one was the heuristic method, where we try to apply some heuristics to identify the modules within the product. That is known as the heuristics method. And we identified there are two methods, or there are three major heuristics we use, and they are known as the dominant flow heuristics, branching flow heuristics, and conversion transmission heuristics. So, using these heuristics we try to identify the potential modules, and then we look at the overlap of these modules, and based on the design team's understanding and the requirement of the product, finalize the modules. So, once the modules are identified, then you can create a layout of the product to see how these modules can be arranged, so that you will be able to make a complete product to meet the customer's requirement. So, that is what we discussed, and we saw a few examples also. How do we convert how do we use these principles to identify modules. So, with that we come to the conclusion of module the product architecture. So, the next step is basically to see how can we give shape to these modules. So, we identified as this architecture, we identify many modules for a product, saying that okay, we need to have a T containment module, or we need to have a conversion transmission module, or we want to have a water containment module. Now, as a designer, you need to see how can we have a T containment module or a water containment module, which is not same as what everyone is providing. You want to have a new design for it, or you do not want to copy somebody, or you want to have your own design, so that it can actually meet the specific requirement of the customer. And that actually comes from developing concepts for this product or the modules. So, it can be a concept for the overall product, or it can be a concept for a particular module, or more specifically for a particular function also. So, that is the next stage where we go to the development of concepts for these functions or modules or the product. So, we will go to the concept development as the next step, or probably the final step, that final thing that we will be discussing in this course. We will look how concepts can be developed for each one of these things. Okay. So, we will move to that topic now. So, as I mentioned, we will be going to the concept generation stage now. So, from the functions to the product architecture to the concept. So, that is the stage where what we have reached now. So, in this stage or in this section, we can see that we are in this stage of product development. So, we are in the develop a concept stage, and there we mentioned that activities in a typical product all activities needed to see what the product should be, that is the develop a concept. Now, we have completed this one portfolio of functional modeling and product architecture. So, the last one is the concept engineering. So, we are at this stage of concept engineering in the product development. Okay. So, most of you must have done a lot of design in many applications, either it is a very small one or a slightly complex one. We will always be doing something related to design. So, whenever we try to solve a problem, that actually is a kind of a design. Now, as a designer, you will be encountering with many such design issues. For example, you want to develop a new portable video player for high-end market, or a company is interested in developing high-end video player, or you want to develop a new nailing device for domestic use. So, you can see this kind of nailing, this is the normal way of you do the nailing, hammer, and it will always create a lot of issues. Well, you want to convert this into an electrical nailing tool, or you want to improve the existing washing machines to meet specific customer needs. So, these are the starting point for a new product development. And then what we will do, if you want to develop this one, you have to look at we have to go through all these steps, and then identify the critical areas where you can contribute in the design. Because when you do a functional decomposition, you identify the product architecture, you identify the modules, and you are not going to change everything in the product. When you are bringing a new product, it is not that everything is new or everything is completely different from existing. You will be using a lot of existing thing, but something which you want to contribute, or some area where you want to improve. That is the, for example, here it is saying for high-end markets. So, you have a specific focus, a mission, and you need to see, okay, to satisfy this high end market what should be provided, what module to be provided, and then you try to develop concept for those modules. That is the way how you start. Similarly here, if there are no existing products, then you need to think of many things, and then you need to think of how do you actually provide the necessary functions, and then how these functions can actually be given some physical shape, and to do that you need to develop concepts. So, this is the way how we normally start with the design process. So, whatever it is, I mean, whether it is a washing machine to meet specific customer needs. Some customers say that, okay, I want to reduce the water consumption, that may be a requirement of some customers. Then you need to look at the function blocks which actually uses water, and how the water is being used in the product, what kind of functions are there, and then you try to identify a module which can actually be redesigned to get the specific customer needs. And after all those analysis, you come to the stage where you need to develop a new concept to meet this customer needs. So, then you start developing concepts for that particular module. So, that is the way how we proceed for in the design process. So, now let us take this example for this nailing device and see how we can actually go from one stage to the next stage in the design process. But most of the time we need to look at what existing solution concepts, if any, could be successfully adapted for these applications. It is not that you need to have everything new, as I mentioned. It is not possible to have everything as completely new in any product, and no product will be 100% completely new also. There will be a lot of things which people adapt from different fields. So, before going for the concept development, you need to look at what existing solution concepts can be successfully adapted for your product. Similarly, what new concepts might satisfy the established needs and specifications. So, you have established some specific needs, and you identify the specification or develop the specification. You have to see what kind of new concepts can actually satisfy that, and what methods can be used to facilitate the concept generation process. So, how can we actually do the concept generation? If you need to develop new concepts, suppose you need to develop new concepts for the product, what methods can be used to facilitate the concept generation process. So, these are the things what we need to look in the concept development, or when you try to develop new product or new concepts for products, we need to keep these things in mind, and then see how we can use the existing concepts or adapt the existing concepts, or what kind of new concepts need to be developed, and how can we generate these concepts in a systematic way. So, these are the things that we will be discussing, or we need to be aware of when we go for concept generation. So, conceptual design, a product concept is an approximate description of the technology, working principle, and form of the product. When we are trying to develop a concept, the conceptual design or a concept is an approximate description of the technology, working principles, and form of the product. So, what kind of technology you are going to use, and what is the basic working principle, and what is the form, and how does it look like. So, that is basically the form, and that is basically known as the concept of a product or a module, whatever it is. And it is a concise description of how the product will satisfy the customer needs, and the quality of underlying concept greatly influences the success of the product. Okay, so that is conceptual design. So, we will discuss this in the next class. I do not want to continue now. I will stop here, and we will see how the conceptual design can be systematically approached, and quality concepts can be developed. So, we will discuss this in the next class. Thank you.